Hello everyone, today we're going to talk about the values of primary trigonometric ratios on obtuse angles and compare them to the primary trigonometric ratios of acute angles. Before we do that, let's recall what an acute angle is and what an obtuse angle is. Acute angles are angles that are less than 90 degrees. And obtuse angles are angles that are greater than 90 degrees but less than 180 degrees. Okay, so far we have seen the values of primary trigonometric ratios of acute angles, and today we're going to study we're going to discover the value of primary trigonometric ratios of obtuse triangles. Before we get there, let's recall the equation of a circle in the Cartesian plan. The equation of the circle in Cartesian plan is x squared plus y squared equals to r squared, where r represents the radius of the circle and x and y are the coordinates of any point on the circle. Now, if the radius of a circle is, let's say, 5 centimeters, and we know that the circle is centered at the point 0, 0, the origin of the Cartesian plan, then the equation will look like x squared plus y squared equals to 25. Okay, r squared, r is 5, so equals to 25. And if we choose any point P on the circle, then that point can move around from 0 degrees and anywhere in a circle up to 360 degrees. So the circle is 360 degrees, and our point P can be at any point of the circle with coordinates x and y. Okay, so as we have refreshed this now, what we're going to do, we will, let's look at this first diagram here when we have the circle x squared plus y squared equals to 25, so the radius is 5, and we're choosing a point P on this circle. Okay, so let's choose the point P, and from that point we will take a vertical line, oops, let's erase that. On the x-axis, a vertical line on the x-axis, and connect point P with the origin, and we create this right angle triangle here. Okay, because it is a right angle triangle, we're going to label the sides as opposite, adjacent, and hypotenuse, here. All right, and we know that from here we can write all the trigonometric ratios, primary trigonometric ratio of this angle theta here. Okay, now what if instead of labeling the sides as opposite, adjacent, and hypotenuse, we use the information that we have from the circle? Now we know that the point is at point P is has coordinate x and y. Okay, so x and y here, and the hypotenuse is the radius of the circle, in this case is 5. In general, if instead of O, this height here is the y value of the point P, so instead of opposite we can write y. Okay, so we're substituting the coordinates and the information that we have from the unit circle, or from the circle and the point P on that circle. So this side, that is the opposite side of angle theta, is the y value of point P, right? So this value here is equal to that value here. So this is y. X, the adjacent side, is equivalent to the x value of the point P. And of course, the hypotenuse is the radius of the circle. Does that make sense? So instead of opposite, we have the y value of the point, because that is the height of this point here. And then instead of the x value, we have instead of the adjacent, we have the x value of point P, and instead of the hypotenuse, we have the radius of the circle. Okay, so from here now, can we write the primary trigonometric ratios in terms of x, y, and r? So we know that sine of angle theta is opposite over hypotenuse. Opposite now is the y value, okay, and hypotenuse is the r value. So sine of theta in the Cartesian plan will be y over r. The same approach for cosine of theta. Cosine is adjacent over hypotenuse. Adjacent now has the value x, and hypotenuse again r. So cosine of this angle theta is x over r. Tangent is opposite over adjacent, y over x. So take a moment to see the connection between the primary trigonometric ratios expressed in terms of x, y, and r of the triangle that is built on the Cartesian plan. Okay? Now, let's move on to the next slide. We're going to use specific values here. So now we're going to give point P. We're going to take point P with coordinates 3 and 4. And we're still on the circle with a radius of 5 units. Okay, so now our y is 4 centimeters, x is 3 centimeters, and r is 5 centimeters. And we're going to write the ratios in terms of these values. So sine of angle theta equals to opposite is 4 over hypotenuse, that is 5. So sine of theta 4 over 5. Cosine of angle theta is adjacent over hypotenuse, x over r, or 3 over 5. Okay? Tangent the same way. Tangent is opposite over adjacent, or y over x. Y is 4, x is 3, therefore tangent of this angle theta is the ratio 4 over 3. Okay? Now that we have the ratio of this primary trigonometric ratios, we can figure out what is the measure of angle theta by using the inverse of any of these functions. And because we're dealing with the same angle, that value will be the same. So give it a try in your calculator. Take the inverse of sine of the ratio 4 over 5, and you're going to see that the measure of angle theta is 53. And as you do the same with cosine, for the specific value, inverse of cosine of 3 over 5 and inverse of tangent of the ratio 4 over 3, you're going to get the same value, and it makes sense, right? All right, let's move on to the next example. In this example now, the point P is on second quadrant. So the coordinates of point P are -3 and 4. And we'll look at the triangle here, POQ, and the angle created by the x-axis and the radius is angle beta here. We call that beta. You can use any other letter if you want to. And we're going to write the primary trigonometric ratios in this triangle. Now, the angle from the positive side of the x-axis to the radius of the circle is angle theta. Now, as you see, this angle theta is located on the second quadrant. That means that is greater than 90 degrees and less than 180 degrees. So theta is an obtuse angle. All right? Now, let's see what's happening with the primary trigonometric ratios. So the primary trigonometric ratios of theta will be equivalent to the primary trigonometric ratios on this triangle here. Sine of theta equals to y over r. Now y is still positive, 4. The y value of point P is 4, and the x value is -3. So sine of theta will be 4 over 5. Cosine of theta is x over r. X over r. X is on the second quadrant are negative, in this case -3. Therefore, cosine of theta will equal -3 over 5. Same way for tangent. Tangent is opposite over adjacent, y over x. X is negative. Our ratio will be negative 4 over 3. So as you see here, only sine has a positive ratio on the second quadrant. Both cosine and tangent are negative. The value of cosine and tangent ratio are negative on the second quadrant. All right, let's look at the next example now. So in this example, we'll carry on what we did on the example 2. We have the point P with coordinates -3 and 4, and the ratios of all three primary trigonometric ratios, the same approach as on example 2. Sine of theta 4 over 5, cosine of theta -3 over 5, and tangent of theta -4 over 3. And we're going to figure out what is the measure of angle theta by using the inverse operation for each one of these trigonometric ratios. And we start with sine inverse of sine of theta. Inverse of sine of 4 over 5 equals 53 degrees. And then we do the same for cosine. Inverse of cosine of, careful when you plot this in your calculator, -3 over 5, close the bracket, is 127 degrees. And if you do the same for tangent, taking the inverse, you're going to get the angle -53 degrees. So even though we're dealing with the same angle, we got different values. So that means that something is not going right here. We need another method to figure out, to properly figure out the value of theta. Okay, as you notice here, the same angle, and we have different values based on these calculations. All right, so we know now that in our calculator, the calculators provide us value of primary trigonometric ratios only and for acute angles. Now, what do we do if we need to determine the primary trigonometric ratios of obtuse angles, of angles that are located in the second quadrant? Okay. When we do that, for example, in this angle here, 0.34, when we had point P at 3,4, with coordinates 3,4, we calculated the angle theta is 53 degrees. Now, for the angle theta, let's look at this a little bit more up close. Angle theta and angle beta here are equal. Okay, is the same angle. So that means that angle theta on the first circle here is 180 minus 53, because these two angles are equal to each other. Okay, so whatever acute angle the calculator is going to give us, we're going to subtract that from 180 to find the length of angle theta on the second quadrant. Okay, so this is angle theta that we're looking for on the second quadrant. Our calculator is going to give us the value of this angle here, angle beta, that we call that beta. To figure out the value of theta, we're going to subtract from 180 the value that we got here of this acute angle to find the value of angle theta. So 180 minus whatever we got here, 53 equals to 127 degrees. Okay. So if we had to go back to the first example that we had here, then we can write here that angle theta equals 180 degrees minus 53 degrees equals 127. We got 127 for cosine directly from the calculator, so we leave that alone. And here now we're going to have the negative sign, so we're just going to subtract the value of the function. So again, it's going to be 100 and, of the angle minus the 53 angle. So this is the negative angle, and we count clockwise when we talk about negative angles. So we're going to start from here, counting up, and whatever is left, that is the angle theta that we're looking for. So it's safe to write 180 minus 53. Oh, sorry, I wrote 180 here. That is 127. All right, so that will be 127 here degrees. All right, putting this all together, for all the angles or primary trigonometric ratios that are on the first quadrant, we know we're dealing with acute angles that are less than 90 degrees. How we measure them? We start from the x-axis and go to the line that connects the point of the origin. Okay, so this is angle theta, and all primary trigonometric, all the angles in this quadrant are acute angles, less than 90 degrees. And all primary trigonometric ratios are positive. For angles now that are more than 90 degrees, but less than 180 because they are only on the second quadrant, those are what we call the obtuse angles. And to obtain the measure of the angle from the positive side of the x-axis to the quadrant 2, we are going to subtract the angle that we found for the acute angle minus 180. And angle theta and beta, we said they are equal to each other. Therefore, the measure of the acute angle will be 180 minus the acute angle that we figured out. So the measure of the will be that. Okay. All right. So here we have another table that summarizes the ratios on the first quadrant and on the second quadrant. First quadrant, as we said, we have acute angles only, less than 90 degrees. All primary trigonometric ratios are positive because both x, y, and r are positive. For obtuse angles, only sign is positive because only y value is positive, x is negative on the second quadrant. Therefore, any ratio that has x on its as the variable on its ratio, any trigonometric ratio that has x will be negative, and those trigonometric ratios are cosine and sine. Okay, so cosine and tangent are negative on the second quadrant. All right, again, here is another summary. Please make sure you write this on your notes and fully understand it. On first quadrant, all three primary trigonometric ratios positive. On the second quadrant, we're dealing with obtuse angles. Only sine is positive. Both cosine and tangent are negative. And keep in mind, obtuse angles are greater than 90 degrees and less than 180 degrees. All right. Let's do a few examples to understand what we talk about so far. Is asking us if point Px, in example 1, if point P with coordinates x, y is in quadrant 1 or quadrant 2, given the following information. Okay, so we have angle 35 degrees here. We have angle, let's call it theta or whatever, 35 degrees. All right, let me try to build some straight lines here. All right, 35 degrees is on the first quadrant. That means is 35 degrees is less than 90 degrees. That means it's in the first quadrant. 127 degrees is greater than 90 degrees and less than 180. Therefore, is on the second quadrant. 95 degrees, second quadrant again, because is more than 95 degrees. Now, based on the value of the angle, can we determine if the value of the sine is going to be positive or negative? 45 degrees, first quadrant, sine is positive. 67 degrees, first quadrant, value of sine is positive. 153 degrees on the second quadrant. This angle 153 is on the second quadrant, but sine is positive first and second degree. Okay, so we safely can say that this value of sine for all these three angles is a positive, will be a positive number. Okay, let's move to the next one. Is cosine positive or negative for each one of these angles? Now here is important to analyze that carefully, because we know that cosine is negative in the second quadrant. Okay, so it's positive on the first one and negative on the second quadrant. So 168 is an angle that is less than 180 but greater than 90. Therefore, second quadrant cosine will be negative. 32 degrees is an acute angle on the first quadrant, therefore will be positive. 114 in the second quadrant will have cosine will have a negative value for this angle. Now the same thing for tangent. Tangent again is positive on the second quadrant and negative on the positive on the first quadrant and negative on the second. So angle 123 is on the second quadrant. Therefore, tangent will be negative. 22 is an acute angle on the first quadrant. Tangent will be positive. 102 is an angle on the second degree. Tangent will be negative. All right. Now here is a combination of what we've did so far. We have tangent of 40 degrees. Tangent of 40 degrees on the first quadrant is positive. 40 is an acute angle, positive. Tangent of 150 degrees. 150 is an obtuse angle located on the second quadrant. Tangent there is negative. Cosine of 120. 120 again is an obtuse angle located on the second quadrant. Cosine is negative there. Sine of 101 degrees. 101 is an obtuse angle located on the second quadrant, but sine is positive in both first and second quadrant, therefore will be positive. Sine of 13 degrees, angle 13 is on the first quadrant, sine is positive. All right, now from here we have in example 5, we have the value, the ratio of a given angle, the ratio of a specific primary trigonometric ratio, and we have to conclude if the angle of that ratio is obtuse, acute, or neither. And by neither we mean like is greater than 180 degrees. All right, cosine of angle A equals 0.35. Now cosine of angle cosine is positive on the first quadrant. Therefore, angle A must be an acute angle, or must be in the first quadrant. Tangent of angle A equals negative 0.72. Tangent is negative on the second quadrant. Therefore, angle A must be an obtuse angle. Sine of angle A equals 0.99. Now, sine is positive on both quadrants, right? That's what we said. Sine is positive in both quadrants. That means that angle A can be both acute and obtuse. Okay, so we're going to have two values for this same ratio for sine. So be careful here. For sine, we always, if sine is positive, that's what we're going to cover in this course when sine has positive values. On first and second quadrant, we're going to deal with acute and obtuse angles. All right, let's move on to the next example. In this example, we have angle P as an obtuse angle. Determine the measure of angle P for each. Well, here we have just an example. So sine of ratio is 0.45, and we need to find the value of the obtuse angle, okay? So first, let's find the acute angle. Sine of theta equals 0.45. We're going to take the inverse of the function, and there we have angle theta equals 27 degrees. Okay, but this is the acute angle that's going to be located on the first quadrant. We are asked to find the obtuse angle, and as we mentioned earlier, the obtuse angle is 180 degrees minus 27 degrees equals 153 degrees. Let's put the sign here for the degrees. Okay, so every time when we have a ratio and we're asked to find the measure of the obtuse angle, we're going to find first the measure of the acute angle, and we're going to subtract that acute angle from 180 to find the measure of the obtuse angle. All right, here we're asked angle K is between 0 and 180 degrees. Is angle K acute or obtuse? Determine the value of K. Okay, and we have different values here. We have tangent of K equals 0.8. That is an acute angle because tangent is positive. Tangent is positive for angles that are on the first quadrant. Okay, therefore angle K is located on the first quadrant, therefore is acute. Finding the value of angle K, we're going to take the inverse of tangent. Inverse of 0.8 equals 39 degrees. On the second example, that should be B. Okay, part B and C here. Tangent of K equals negative 0.8. What kind of angle is this? Now, since tangent is negative, that means it's going to be located on the second quadrant. That means that we're dealing with an obtuse angle. When value of tangent, when ratio of tangent is negative, we're dealing with obtuse angle. How do we find out now the value of K? First, again, we're going to find the value of the acute angle. Tangent of, you see how we dropped the negative here so we don't have to deal with the negative angles. So in your calculator, you're going to write tangent, inverse of tangent, 0.8 equals 39 degrees. That, by dropping the negative sign, you're going to get the acute angle on the first quadrant. You're going to take that and subtract it from 180 to get the obtuse angle that has the ratio of tangent at negative 0.8. Now, sine of angle K is 0.8. We know that sine is positive in both quadrants, so we're going to figure out both values of the acute and obtuse angle. First, we find the obtuse angle, the acute angle, taking the inverse of sine of 0.8, your calculator will give you 53 degrees. Now we're taking that, subtracting it from 180 to find the measure of the obtuse angle. Okay, hope that makes sense. The last example that we're looking at, from this primary trigonometric ratios, we're going to identify if angle M is between 0 and 180 degrees. Okay, so we have tangent of angle M at 0.83. Now, since tangent is positive, that means that angle M will be an acute angle. That means that it is between 0 and 180 degrees. Okay, and will be an acute angle. Sine of M now is negative 0.76. But what we've covered so far, what we've seen is that sine is positive. And for sine to be positive, the angle will be between 0 and 180. But since this is negative, that means that our angle M is greater than 180. Okay, so it's going to be somewhere between 180 and 360, and we're not interested on that in this course. Okay, so it's going to be somewhere here in quadrant 2 or quadrant 3. So angle M is not between 0 and 180 degrees because sine of M in these two quadrants is positive. Okay, that was the last example that we are going to go over. Please go over the examples. Make sure that you understand each one of them. And for extra practice or for practice, go to page 23 in your textbook and work with problem 1, 2, 3, 4, 7, and 8. Okay? That is the end of the lesson. Bye for now.